Hello, let us start the review with triangle. We know that the angles of the triangle are expressed through the unknown variable x, and we want to find this x. For the triangle, we have a theorem that tells that the sum of all three angles of the triangle must be equal to 180 degrees. Let us add all three measures together. X plus 30 plus 220 minus 3x, and it must be equal to 180 degrees. And we solve this equation for x. So we have like terms here. X plus x minus 3x with a negative x. 220 and 30 together will be plus 250 equals 180. And we can add x to the left and to the right and subtract one. Let us do it step by step. 250 equals 180 plus x and subtract 180. 250 minus 180 will be 70 degrees. X equals 70 degrees. So you can find two other angles substituting 74x. In the next problem, we are given the point 2, -5, and we want to find sine and cosine of theta if the terminal side of the angle theta goes through this point. We need a Cartesian coordinate system, and we plot this point. X coordinate is 2, and y coordinate of the point is -5. So in the ordered pair, first is x, second is y. So this is the point on the terminal side of the angle theta. Positive or negative doesn't matter. To find sine or cosine, we need one more value. We need to find r. We can consider one of these right triangles and write the Pythagorean theorem for this triangle. X squared plus y squared equals r squared. X squared 2 squared plus -5 squared equals r squared. Negative squared is always positive, so we have 4 plus 25 equals r squared. So r equals square root of 29. Of course, we take positive square root because distance can be only positive. And now we can determine sine or cosine, whichever is asked in the problem. Sine theta is y over r. Y is -5. -5 over square root of 29, and we want to rationalize it. We multiply by square root of 29, numerator and denominator, -5 square root of 29 divided by 29. And cosine theta equals x over r. X is 2, so 2 over square root of 29, or 2 square root 29 divided by 29. In the next problem, we want to find arc length given theta and radius. So the formula for the arc length is S equals r theta. And don't forget that theta must be in radians. R is 14. 330 degrees is the angle in the fourth quadrant. 30 degrees reference angle. 30 degrees is the same as pi over 6. So we have 2 pi minus pi over 6 2 pi is 12 pi over 6. 12 pi over 6 minus pi over 6 will be 11 pi over 6 multiplied by 11 pi over 6, and we can simplify by dividing numerator and denominator by 2. So 20 times 11, 225 divided by 3 is the arc length. Determine the equation for the graph of trigonometric function. First, we have to choose what kind of a function do we have. So the two limited functions are sine and cosine, and this is the typical sinusoid or cosinusoid. So when it starts from the middle, it is sine. Sine has 0 at 0 of the argument. So the cosine wave will start from minimum or maximum. So maximum if it is positive, minimum if it is negative. So sine starts from 0 and it increases at the beginning, so it's positive sign. Then we can tell the argument, the amplitude of this sign. It oscillates between -4 and 4. So the amplitude is 4. Then the period. So the period of the function, we have 3 complete periods on the interval 2 pi. So period is 2 pi divided by 3. So one complete period is 0, maximum, minimum, 0. This is one period of a sine function. So, and we have 3 periods on 2 pi, so the length of one period is 2 pi over 3. To write the function equation, we need b. And we have the formula connecting b and pi. B equals 2 pi divided by p, period. Let us find b. 2 pi, we want to divide by 2 pi over 3. It is the same as multiply by the reciprocal. 2 pi must be multiplied by 3 over 2 pi. So we multiply the fraction 3 over 2 pi by 2 pi. It means that 2 pi is multiplied by the numerator of the fraction. Okay, then we have 2 pi in the numerator and 2 pi in the denominator that can be cancelled out, and b equals 3. And we write this 3 in the function equation. 3x. 4 sine 3x is the equation of this function. Find the tangent of a sum or a difference of two angles. One of them is unknown, another is a special angle, another is an unknown angle. And we want to express this tangent of a sum or of a difference in terms of tangent of x. So we apply the formula for tangent of a difference. Tan x minus tan 30 divided by 1 plus tan x tan 30. So if we have minus in the numerator, then we have plus in the denominator. 30 degrees is a special angle, so we know the tangent of this angle. Let us look on the unit circle or use the reference triangle. So 30 degrees is this smallest angle in the unit circle. The tangent is 1 over square root of 3 or square root of 3 over 3. Tangent of 30 degrees, we substitute. Let's substitute it in this form, and we get tan x minus 1 over square root of 3 divided by 1 plus 10x times 1 over square root of 3. And we don't want these denominators, these fractions in numerator and denominator, they have the same denominator. So to rid of this, we multiply by square root of 3 the whole numerator and the whole denominator. Square root of 3 is the less common denominator for all these terms. So we have square root of 3 times 10x minus 1 divided by square root of 3 plus 10x. Find the exact value of 1 minus 2 sine squared 75 degrees. Notice that this expression looks similar to the formula for sine or cosine of double angle. Cosine 2 alpha equals. For cosine of a double angle, we have 3 different formulas, and one of them is 1 minus 2 sine squared alpha. So you see this is almost the same as this, so we can complete this expression according to the formula for double angle. It must be equal to cosine of double angle of 2 times 75 degrees, or cosine of 150 degrees, and this is the special angle. We can find it on the unit circle. 150 is 180 minus 30. Here is 150. So 30 degrees reference angle. So cosine of 30 is square root of 3 over 2, and here we are on the negative part of the x-axis. So cosine is negative square root of 3 over 2. Find sine 2x when sine x is 1/4 and x in quadrant 2. Let us make a sketch of this angle, x. Sine is quadrant 2, sine is positive 1 over 4. Sine is by definition y over r. So we can take a point with the coordinates x equal or y equal to 1 and with distance to the origin equal to 4. So this is the terminal side of the angle, denoted x here. So let us take theta beta, theta. So this is the angle theta. So we have two ways how to solve it. So either you use trigonometric identities, you know that cosine theta can be found as plus minus square root of 1 minus sine squared theta from Pythagorean identity. Or you use the coordinates of this point. You know that y equals 1, r equals 4, and Pythagorean identity x squared plus y squared equals r squared. Substituting, let us follow this way. X squared plus 1 squared equals 4 squared. X squared plus 1 equals 16, and x squared equals 15. So to solve such an equation, we use square root property, and generally the solution looks like this: x equals positive or negative square root of 15. So we choose positive or negative sign depending on the situation. So we are in the second quadrant. It means that x must be negative. So we take negative sign. X equals negative square root of 15. So why do we use x? x actually, since from x we can determine cosine theta, which is x over r, negative square root of 15 over 4, and then we can find sine of 2x. So actually we should start from this. So we have a sine, the formula for sine of double angle, sine 2 theta equals 2 sine theta cosine theta. Yes, sine theta is given, cosine theta we have found, we substitute them, equals 2 times 1/4 times negative square root of 15 over 4. And simplify, so we'll write negative sign in front. And then in the numerator we have 2 and square root of 15. And in the denominator we have 4 times 4. We can divide by 2, numerator and denominator. So we get negative square root of 15 over 8. Find the sine of 105 degrees using half angle identity. You know that you can find such an angle using sine sum identity or half angle identity, and the solution will look very different. So that's why to specify, please use half angle identity here. So half angle identity for sine is a minus under the square root, so sine of alpha over 2 equals plus minus square root of 1 minus cosine 2 alpha. Oh, sorry, here's alpha over 2, so cosine alpha divided by 2. So 105 degrees is alpha over 2. Alpha over 2 equals 105 degrees. It means that alpha in our identity must be equal to 2 times 105, or 210 degrees. So sine of 105 equals plus minus square root of 1 minus cosine 210 divided by 2. So what should we choose, plus or minus, depends on the quadrant. 105 degrees is greater than 90 but less than 180. It means that we are in the second quadrant. In the second quadrant, y coordinate is positive, so sine is positive. We choose positive sign. And we substitute the value of cosine of 210 degrees. It is a special angle. We know the values, the cosine value of this angle. 210 is 180 plus 30. This is 210. 180 plus 30, so special angle is, reference angle is 30 degrees. Cosine of 30 is square root of 3 over 2. Here we are on the negative side of the x-axis, so cosine of 210 over negative square root of 3 over 2. We substitute in the formula for sine. We get square root of 1 minus negative square root of 3 over 2 divided by 2. So negative times negative will be plus, and let us multiply by 2. Numerator and denominator is this fraction, so we want to simplify it a little bit. We get 2 plus square root of 3 in the numerator and 4 in the denominator. We multiply it by 2, numerator and denominator. And one more step, we can take square root numerator and square root of the denominator. So square root of 4 will be 2. Sine of 105 degrees is square root of 2 plus square root of 3 divided by 2. Solve the equation 2 sine x plus minus square root of 2 equals 0 for all solutions. To solve the equation, we isolate the unknown, the trigonometric function sine x. So let us take plus here, not plus minus, but plus. We subtract square root of 2 from the left and from the right. 2 sine x equals negative square root of 2 and divide by 2. So sine of x equals negative square root of 2 over 2. Let us look on the unit circle. Sine is negative at the third and the fourth quadrant. Negative square root of 2 over 2 is the sine of a reference angle 45 degrees or pi over 4. So these two angles satisfy this equation. And first of them, so if we talk in degrees, 180 plus 45 degrees or 225 degrees, and 360 minus 45, 315 degrees. Sine is a periodic function with the period 360 degrees. So we can add 360 times n to each of these solutions. So we get two series of solutions. 225 plus 360 times n and 315 plus 360 times n. This is in degrees, or in terms of pi, the same solutions can be written as x equals, here we have 4 pi over 4, 5 pi over 4, 5 pi over 4 plus 2 pi n, and the complete rotation is 8 pi over 4 minus 1/7 pi over 4 plus 2 pi n. So either this or this pair of solutions. And n can be any integer. Solve the equation involving inverse function y equals arc sine of negative 1/2. So we'll find the real number y, which is equal to arc sine of negative 1/2. So to find y, it is reasonable to rewrite it in alternative form. Then the trigonometric function goes to the left and without this inverse sign, without arc. Sine y equals negative 1/2. So if y is the arc sine of negative 1/2, that means that sine of y equals negative 1/2. Let us look at the unit circle. Sine is negative in the third and in the fourth quadrant. But you remember that sine inverse or arc sine is determined only in the first and in the fourth quadrant. So if it is positive in the first and if it is negative in the second, so we have a negative sign. So we take only the fourth quadrant. Sine is 1/2. So the reference angle is 30 degrees or pi over 6. And arc sine is determined from negative pi over 2 to 0. So we consider not the positive angle 11 pi over 6, but the negative angle negative pi over 6. So y must be equal to negative pi over 6. If it were arc cosine, y equals arc cosine of negative 1/2. Then the equivalent equation will be cosine y equals negative 1/2. And negative cosine is determined in the second quadrant. Positive in the first and negative in the second. Cosine is negative 1/2 for the angle with the reference angle 60 degrees. Then the x-coordinate is negative 1/2. And this is the angle 2 pi over 3. So pi equals 2 pi over 3. So you see the difference. If it is sine inverse is of negative value, it is negative angle. If cosine inverse of a negative value, it is a value from the second quadrant. For arctangent x equals 5 pi, so the equation involves inverse function. We first isolate this function. We divide by 4, and arctan x equals 5 pi over 4, and then we rewrite the equation in alternative form, so without arctan. So function goes on another side of the equation without arc sign, without inverse sign. So x equals tangent of 5 pi over 4. That's all. So 5 pi over 4. Let us find this angle on the unit circle. Pi is 4 pi over 4, so 5 pi over 4 is here in the middle of quadrant 3. 5 pi over 4. And tangent is sine over cosine, or y over x. Y and x have both the same absolute value and both are negative, so the tangent will be positive 1. So x equals positive 1 here. In the following triangle, we want to find one of the sides given two other sides and the angle between them. It is a situation of a case for law of cosine, and we can write law of cosine for the side x. X squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of the angle between them, cosine of 45 degrees. So x squared equals 49 plus 100 minus 140 times cosine of 45 is square root of 2 over 2, and we can simplify it. So 49 plus 10, 59 minus 70 square root of 2. Two more problems for trigonometric identities. So given that cosecant alpha 5 over 3 and alpha is in the quadrant 2, find cotangent alpha. We have an identity, one form of the Pythagorean identity that connects cosecant and cotangent. So I can remind you how we got this identity. For the unit circle, we have x squared plus y squared equals r squared. If you divide by, or sine squared theta plus cosine squared theta equals 1. If you divide this identity by, so we want to get cotangent, so cotangent will be x over y. So if you divide this identity by y squared or this identity by sine squared theta, you will get the same identity. So x squared over y squared plus 1 equals r squared over y squared, or if you look here, 1 plus cotangent squared theta equals 1 over sine squared, which is cosecant squared theta. So and this is the same actually. So from the Pythagorean identity, you can get another form, alternative form of the Pythagorean identity connecting cotangent and cosecant. So, and we can use this identity to solve our problem. We know the value of cosecant, 5 over 3, and we can find cotangent. So let us subtract 1 from the left and from the right, and use alpha instead of theta. Cotangent squared theta equals cosecant squared alpha minus 1, and substitute 5 over 3 for cosecant squared. 25 over 9 minus 1. To subtract fraction number, let's represent 1 as a fraction 9 over 9. 25 over 9 minus 9 over 9. 25 minus 9 over 9. 16 over 9. Now we want to find cotangent. So we got this cotangent squared alpha equals 16 over 9. To find cotangent, we apply square root property. Take a square root of this equation. So cotangent alpha equals positive or negative square root of 16 over 9. So be careful, don't forget this positive or negative sign. We are in the quadrant 4. Cotangent in the second quadrant is negative. So we choose negative square root of 16 over 9. So in this case, in this example, we can simplify it, take square root of 16 and square root of 9, not always so. So negative 4 over 3 is the value of cotangent. And now the problem for applying identities. Something like this: secant alpha times tangent alpha divided by cosecant alpha. So if you don't have some identity that connects all the values together, like in previous example, the best way to solve it to write all functions in terms of sine and cosine. Secant, so you see C means that it is 1 over cosine. So here's S and cosine is C, 1 over cosine alpha. Tangent is sine over cosine, and cosecant, so here's C, that will be 1 over S, 1 over sine alpha. So, and how can we simplify here? Let us read off this fraction in the denominator and multiply all the expressions in the numerator and denominator by sine alpha here and by sine alpha here. We don't have this denominator anymore, and here we have sine over cosine. We can write this sign here by this fraction. So when we multiply fraction by something, we write it in the numerator. So when we can write it in this numerator, and we have sine over cosine times sine over cosine tangent square alpha. So you will have something different here, but the way to solve it is to write in terms of sine and cosine. And 3 simple problem that you're familiar with from the last exam. So cosine 10 times cosine 330 plus I sine 330, write it in the algebraic form. Just substitute the values of sine and cosine. 330 is in the fourth quadrant, this angle with the reference angle 30 degrees. So its cosine is positive square root of 3 over 2, 10 times positive square root of 3 over 2, plus I, imaginary unit, times sine. And sine is negative 1/2. So you see the longer leg is cosine, it's a square root of 3 over 2. The shorter leg is sine, negative 1/2. Negative 1/2. And we can distribute 10 over the sum and get 10 square root of 3 over 2 minus 10 over 2i, dividing 10 by 2, we get 5 square root of 3 minus 5i. The last two problems you have seen on the last review, they were moved from the third exam to the final. So find the quadrant of the number given in polar coordinates like 50 and 350 degrees. So if you have polar coordinate, that means that the first number is r, is the distance from the origin. The second number is the angle given in counterclockwise direction as a normal, as it is normal in trigonometry. So 350 is greater than 270, but less than 360. We are in the quadrant 4. So the question is, what is the quadrant? Quadrant 4. And the last problem that I see here, if I'm not wrong with numbers, is x equals 42 cosine t, y equals 42 sine t. So, and t is 3 pi over 2. Let us take this. So, and find the ordered pair xy. So we substitute, for example, 3 pi over t over 2 for sine and cosine. Cosine of 3 pi over 2 is 0, so x is 0. Sine is negative 1, so y is negative 42, and ordered pair is 0, negative 42. And I think I skipped one number on it, so it must be altogether 18. It was the equation, a simple equation like cosine theta equals positive or negative, so let us say negative square root of 3 over 2. But we have solved a couple of equations for another problem. There will be several problems involving solving such an equation. So the exam looks to be difficult, but I think you are ready to take it, and I wish you good luck.